Hello students, welcome back to my channel. Previous session we had learned an algorithm where we learned how to remove duplicate elements from an array with using an additional extra array. So in today's session we will continue the same topic, that is removing the duplicate element, and we are going to discuss another method where we can remove the duplicates without using an additional array. So let us see how we can do that. So first, let us see the problem statement. So problem statement tells us that we have to remove all the duplicates from an ordered array. So an ordered array is given, and if at all there are repetitive values, so we are supposed to generate an array without the repetitive value. So that is a task. Next, given a sorted area, this should be array. Given a sorted array, we should remove all the duplicates from the array such that each element appears only once, and the array should be ordered after removing the duplicate elements. So that is what the given task is. So how can we do that if at all we do not have an additional array? Like in the last session, if you remember, we had an array. Suppose let me take 11, 21, 21, 34, 34, 50. This is the value. In the previous session, what we had done is we had taken another array and we were comparing the values, and the moment we find an array which is or a value which is duplicate, we were only taking one value and then we were writing it over here. Something like this was the output. But in today's session, we will see without using an additional array, how can I do that? So let us see how we can do it without using a additional array. Let me take the values, that is 11, 21, 21, 34, 34, and 50. So what I'm going to do is I'm going to take two variables, for examples I and j, and this is going to track my array. So j is used only to store the values which are not duplicate, and I is used in order to traverse the array and to find out if there are any duplicate values. For example, here I, then I'm going to also take the value of I plus 1. I'm going to compare if I and I plus 1 are same. In this case, they are not same. So what is going to happen is I am going to now simply say that A of j is equals to A of I. Okay, since it is in the same place, that is fine in this first case. Next, what is going to happen? I is going to come here, I plus 1 is going to come here. And then when I'm comparing, these both are same. So in this case, I'm not going to, of course, j value will be incremented. So here I'm not going to write the value for j. As in A of j, I'm not going to mention because they are same. Next, once again, I will increment I and I plus 1. Here, when I'm comparing, these two are not same. Hence, A of I value I'm going to rewrite here and increment the value of j. Let me write it in a different color. So j is going to come here. So next, what is going to happen? Next, once again, I will increment the I and I plus value, and I'm going to compare 34 and 34. When I'm comparing, they are same. Hence, I'm not going to write the value for j. I'm simply going to increment the I and I plus 1 value. So I value, when it is increasing, automatically I plus 1 value is increased. So when I'm comparing here, again, they are not same. Hence, what I'm going to do is write the value of I, that is 34, in the jth position, and simply increment the value of j. Okay, so the till n minus 2, our value is going to get iterated, and last whatever is left, that I'm going to write it anyway at j, that is here it is going to be 50. So if you can see here, my array is, I'm going to print the array only up till array of j minus or j, that is it is going to be 11, 21, 34 and 50. Hence I have removed the duplicate elements from the array and my array is ordered. All right, so now let us see the algorithm and iterate the same values once again. So as you can see, this is the algorithm. I'm going to start declare variables array or array as well as n, I and j. So let me take the values 11, 21, 21, 34, 34 and 50. These are the values. Read n elements from the array. So we have read the n elements. Initial as I is equal to 0 and j is equal to 0. Initially I is 0 and j is 0. Okay, now I'm saying for I is equal to 0 to n minus 2. Now my n value is 6. Okay, n minus 2 is equals to, I'm going to iterate I up till 4. That is, I'm going to iterate it up till here. So if you remember, the index of an array starts from 0. Okay, and I value I'm going to iterate up till 4. That is nothing but till this value I'm going to iterate the I value. All right. So first condition is if ith element is not equal to I plus 1th element. So I is here, that is 0. I plus 1 is this one. Now I'm comparing this and this. Are they equal? In this case, they are not equal. If they are not equal to the ith element, then array of j is equal to array of I. That is nothing but now at array of j, which is nothing but array of 0, I am going to write the value of array of I, which is also 0. Hence, 11 is going to be there at array of j. And then what I'm going to do is increment the value of j is equal to j plus 1. So now j value is going to get incremented. Hence, it is going to point here. And remember, this is a for loop. Hence, automatically I value also going to get incremented. So I value is also going to be 1. Now, once again, I'm checking whether the value of I and I plus 1, that is 21 and this one, are they same? Now, here it is same. So, if the ith element is not equal to, then only I'm going to write at array of j. Since they are equal, then I'm not going to increment the j value, nor I'm going to write the value at array of j. Simply, I will increment the value of I. So now value of I is incremented and I value is over here now. Remember, j is still here. Okay, now once again I'm checking, comparing I and I plus 1 value. In this case, they both are not same. Hence, if ith element is not equal to I plus 1th element, then what we are supposed to do is write at array of j is equal to array of I. So j value is as of now 1. So at array of 1, I'm going to write the value of array of I. That is nothing but 21. Hence, 21 is going to be written over here and also increment the j value. Okay, because of this step. Now after that, once again, I'm going to increment the value of I. So I value is going to get incremented. Remember, j value is also now incremented to 2. Now I'm going to compare. Now I is over here. Compare I and I plus 1th value. In this case also, they both are same. And when they are same, I'm not going to do these steps. I'm directly going to increment the I value. So I value is incremented. Hence, I is now over here. Okay, remember simultaneously we are also checking for the condition. Now, of course, as of now, I value is here. So this is valid. I'm comparing I and I plus 1th value. They are not same. So when they are not same, what I'm going to do is at array of j value is 2. I'm going to write the array of I value, that is 34. Okay, and then increment the j value. So j value was here. So j value is going to be here. So remember, here it was 34. After that, once again, I'm going to go and increment the I value to 5, but then this condition will fail. Hence, I will come out of this loop. Entire loop, I'm going to come out. So once I come out, remember, we still have this value pending here. So store the last value of ARR. So what I'm going to do is at array of j. So j value is now 3. Okay, here we had incremented it. So it is 3 now. Array of j is 3 and array of j is equal to array of n minus 1. N value is 6, n minus 1 is 5. So at the 5 index, we have 50 that I'm going to store at array of j and increment the j value once again. That is array, this is going to be 4. Okay, this step. So once we are done that, print the final array from I is equal to 0 to j minus 1. Okay, so from 0 to what is j value? J value is 4. 4 minus 1 is 3. Hence, we are going to print that is nothing but 0, 1, 2, 3. This is our final array. So this is going to be the final array. So my output is going to be only 4 elements, that is 11, 21, 34, and 50. Okay, so this is the algorithm to remove the duplicate elements from a given array without using an additional extra array. All right, I hope this is clear. So that's all in today's session, students. Thank you for watching.